is going to be pretty much impossible for anyone to see who's watching this video. Luckily, you have a handout that has it written on there. But this says that we're supposed to find the sine of 2 theta, given that sine theta is negative 5 over 12, and it's in quadrant 4. There's a hint on there that says draw a triangle in the 4th quadrant. It's a good idea. I think I will. So sine is my reference angle here. Theta is opposite over hypotenuse. And so I can put that in there. If you want a little reminder in terms of keeping track of your positives and negatives, you actually can put negative 5 right there if you want. I don't usually do that, but you know, if it helps you keep track, go for it. Pythagorean theorem tells us that this value up here is going to be the square root of 144 minus 25. So that's radical 119. Then, there's a rule, a double angle formula, that says sine 2 theta is 2 sine theta cosine theta. This will be given to you on the day of the final. I'm not asking you to memorize that. You'll have a list of your trig identities. That's going to be one of them. So we just apply this to this situation here. I actually almost have enough information right off the bat because I have sine theta already. Negative 5 over 12. And then my last piece here, I just have to put in cosine theta. Well, cosine theta is adjacent over hypotenuse. So this is going to be radical 119 over 12. And then it's all multiplication, so you don't have to worry about common denominators or anything. Multiply that all out, and you'll get negative 10 over radical 119, times radical 119, all over 144. The one on your final is actually going to work out a little bit cleaner than that, but same idea. Let's keep rolling, as soon as I can get through. Triangle here, you're supposed to solve for x. Law of sines looks like a good way to do this. If you remember how that goes, sine of the angle corresponds with the length of the opposite side. So I've got sine 75 over 100, and then I've got 50 and x. So over here I have sine 50 over x. And the law of sines is just telling us that those two things are equal to each other. So if I cross multiply here, I will get x sine 75 is equal to 100 sine 50. So x is going to be 100 sine 50 divided by sine 75. And when you multiply those out, x comes out to be 79.31. Just a heads up, you got to be in degrees for this to work. So last problem we were in radians, this one we're in degrees. But how do I know which one to use? This is how, right here. See that? That means degrees. So the problem tells you which mode to be in. If the problem's in degrees, push calculator degrees. If the problem's in radians, push calculator radians. If you don't like switching your calculator, then just convert your answers. But you got to match it up. So multiple choice test, the choice is going to be based on a degree calculation. You got to get your 79.31. Next one, same idea here, except that if I start matching stuff up, if I try to do law of sines, it doesn't work. I could say 100 goes with x, but 19 it doesn't go with any angle. 25 doesn't go with any angle. So this one's actually going to be a law of cosines. And the law of cosines says that if I've got a side opposite this angle here, that one goes by itself over here. Then I've got these other two sides, 19 and 25, they just get squared and added. Then I subtract 2 times the product of those same two sides, 19 and 25. And then I finally got cosine of my angle. Now, I put this together kind of sloppy on purpose to show you that it doesn't matter. A lot of people get caught up in memorizing this formula, but you don't really need to. You only have these two pieces, 19 and 25. You could put 19, 25, 25, 19. You could put 25, 19, 25, 19. However you want, it doesn't matter. You know, the order that they go in, as long as you have your 19, 25 and your 19, 25 in both spots. And then the only other piece is this 100. Well, that's an angle. There's only one thing that requires an angle. And so it's actually a pretty easy formula to memorize. If you multiply this out, you get, of course, your degrees, you get 1,150. This will for sure be a choice on the exam, and it is very wrong. Because if you got a triangle with sides of 25 and 19, there's no way that this side is going to be over 1,000. Quick look at why you got such a big answer is because you just solved for x squared, right? We're actually asking for x. And so if you put in radical 1,150, then you get your answer of 3393. Vector here, the formula for this vector, which I will not give you on the test, is x2 minus x1 in the I direction plus y2 minus y1 in the j direction. So if I plug in the values that I have, my vector would be negative 2 minus 2 in the I direction plus negative 8 minus 3 in the j direction. And my vector is now negative 4I minus 11j. If you forget that formula and you want to reason your way through this problem, you want to think of this as 2 points, right, which they are. So one of them is 2, 3. And a point right here. The other one's negative 2, negative 8. Point right here. So I've got a vector that connects them. What I'm asking you for are these component vectors listed as i's and j's. And so you're going down here 11, over here 4. Down and to the left, those are both negative values. So you've got negative 4 in the x direction and negative 11 in the y direction. So you could draw it, you don't have to. The formula makes enough sense to you, just use the formula. Try to squeeze in one more because it's super short. You're going to take your final. You're going to see a question similar to this, and you're going to say, booyah, I got this one. Because the first thing you're supposed to check when you're looking for a limit is you're supposed to see, can I just take this value and plug it in directly? And in this case, you can. And you would get 6 over negative 5. That is not undefined. There's nothing wrong with that. You're done. Answer. Easiest, I don't know, 0.8% of your grade you're going to get all year long.